Greetings, everybody, and welcome to my video. Tonight I wanted to show something. This is for everybody that's making windmills and making power coils where they're cutting a conductor with a magnetic field. Okay, the importance of cutting that conductor at a 90-degree angle. You notice my conductor is straight across this way, and the magnets are spinning this way. So I'm cutting these conductors right here to 90 degrees from the rotating magnetic field. Okay, so in this coil right here, this is a quad filer, but we're only using one of the coils inside there. So, and that's what's hooked up to the meter here. Okay, so right now this coil just sitting here is putting out 14.8 volts. Okay, so now I hope you can see this. I'm going to turn this coil just a little bit and watch what happens. See, it's going down. We're at 14.2, and we got just a slight angle there. Well, we just lost 2 volts, almost 3 volts. So the more of an angle you have it, the less voltage you're going to get out of it. And if I pick this coil up and set it perpendicular like that, I get 1 volt out of it. 1 volt. Because I am not cutting the lines at 90 degrees. So if I set it back in the center there, I'll try to center it up there a little bit. I'm back to 14.6. Said I gotta get it in the right place there. 14.8, 14.6, something like that. Okay. So like I said, I'll do it again. I'll just give the coil a turn, and you can see the energy drop. You know, we're not making as much energy now because the coil is not getting cut at 90 degrees in the magnetic field. Okay, now we're back up to 14.6, 14.7. So, yeah, I just wanted to show that it's important. I don't know about Bedini motors. A lot of people are twisting the wires together, but I'm not sure if, you know, that having the one wire running through the coil is giving that coil energy, whether it's in the magnetic field or not, regardless, because of the way that it's wrapped. But then you'd have to wrap it so that your wind is 90 degrees to the magnetic field running through the wire that's wrapped around. Okay, so I don't have any twisted coils. I have never used a twisted coil for any of my Bedini stuff or anything like that. I just run them parallel, side by side, because I want to cut the lines at 90 degrees so I get maximum flux within the coil. So, you know, but that's for a power coil. I'm not, like I said, I'm not sure about the Bedini coil. I've never twisted one up, but you know, it'd be worth an investigation, I guess. So, you know, maybe one of these days I'll make a twisted coil and put it on there and see what it does. You know, but you know, that was one of the reasons why I designed my motor the way that I did, was so that my power coils, when I put a power coil or any coil up there, I am cutting lines. You know, my flux lines are 90 degrees. So, yeah, I'll do it one more time. Give her a twist. I got it twisted like that, you know. So I mean, if you're winding a coil for a windmill, and you wind some triangular shaped coil, and those magnets are going to slice the coil at 90 degrees, you're not getting maximum flux out of it, and you're wasting your wire, basically, because you're not generating any energy within that coil because it's not cutting the, well, it's not generating the maximum that it could. It's not as efficient as it could be, I guess is what I'm trying to say. So yeah, and that couple of volts, I mean, just having it turned like this right there, you know, just that little bit right there brings that sucker down to 13.1, you know, and even just a little bit more, now you're 12.1 right there, you're 12.1. So if you had a triangular coil there, it wouldn't be making anything really, you know. I mean, and that 12 volts right there, 14 volts to charge my battery, 12 volts won't. So that little extra 2.6, 2.7 volts, it makes the difference between charging the battery and not charging the battery, and getting the maximum flux out of your coil and your rotating magnetic field. However you're doing it, whether it's a windmill or, you know, a setup like this, or, you know, whatever, you know. So yeah, I don't know. See, there's the proof, you know, right there. Right there. It goes down to 10 volts there with that angle. So, you know, put it back straight again, and I'm back to making, when I get it centered up on there. Oh, it's pretty centered on there. 4.5, 4.6 volts. But that makes the difference. That's the difference between making maximum, getting the maximum power out of your coil or not. So I hope you enjoyed the video. Have a wonderful day. Peace.